Today's webinar, What's the Missing Piece of the 5G Puzzle? Hint, think mmWave, presented by Qualcomm. I'm Liz Wesky, and I'll be moderating this webinar. Our speakers today are Philippe Poggionti, Vice President, Business Development of Qualcomm, Manish Tripathi, Vice President, Engineering of Qualcomm, and Ozge Koyman, Senior Director, Technology of Qualcomm. You can read their full bios on the left side of your window by selecting the Speakers tab. Just a few technical notes before we begin. The webcast is being streamed through your computer, so there is no dial-in number. For the best audio quality, please ensure that your volume is all the way turned up. This webinar is being recorded and will be available on demand within 24 hours after the event. Time permitting, we will follow the presentations with a Q&A session. Please submit your questions using the Questions and Answers tab on the left side of your screen. Okay, now let's begin. Philippe, please go ahead.
Thank you, Liz, and good morning, good evening, everyone. So let's talk about millimeter wave in the context of the global 5G. 5G is accelerating globally, and we can now say that 5G is all about connecting everyone and everything to the cloud with high quality of service 100% of the time. So you can see that now we are no longer like even counting the number of devices that are connecting to the cloud with 5G. So I think it's now time to look at what millimeter wave is bringing to the equation. So first thing, when you look at the maturity of an ecosystem, we will look at the frequency available. And millimeter wave has the characteristics within the 5G family to have abundant spectrum, like in the example of the United States, we are comparing the C-band bandwidth and the millimeter wave bandwidth available to operators. And then to also cost effectively address data demand and new use cases. So usually in many countries of the world, millimeter wave spectrum is relatively cheap versus other variants and other frequency bands of 5G. The second thing to look at when assessing the maturity of an ecosystem is, of course, the number of countries that have allocated the spectrum and the number of operators that have commercially launched a technology. So in the case of 5G millimeter wave, as you can see on this map of the world, there is a growing presence with US and Japan that have extensively commercialized millimeter wave technology, and a growing number of operators around the world that have started to launch millimeter wave. In the past 12 months, as an example, on the right-hand side, you see in Asia Pacific, a lot of like developed economies have launched millimeter wave, all the way from Korea to Taiwan to Hong Kong, Singapore, and Australia. In Europe and Latin America, a lot of countries have now allocated spectrum to millimeter wave, so we can imagine that a lot of operators will follow the showcase of Fastweb in Italy to launch this year millimeter wave. So in a nutshell, 2022 will be the year of millimeter wave, where key decisions will be made by key countries to allocate spectrum and by key operators to commercially launch millimeter wave. The third thing that you look for to assess the maturity of an ecosystem is, of course, the availability of devices. Now, what is important, you look at the diversity of the form factors. This is one dimension to look at the maturity of the ecosystem. Here you can see the vast number of form factors that have devices with millimeter wave enabled, ranging from smartphones to customer premises equipment, CPEs for fixed wireless access, but also PCs, like always connected PCs that are enabling 5G on the go, including 5G millimeter wave. The other dimension to assess the ecosystem maturity is the number of vendors, the number of OEMs that are providing millimeter wave. We have 33 brands now that are offering some forms of millimeter wave devices. So I would say it's a very good maturity ecosystem. We hope this year, 2022, will be the year of millimeter wave, and hopefully the year where we pass the threshold of 100 million units of devices equipped with millimeter wave around the world. Another proof of the vibrant ecosystem, 40 plus industry players have collectively signed up to commit to support 5G millimeter wave in June of last year at the Mobile World Congress Barcelona. And also in November of last year, the GSM Association have launched the millimeter wave Accelerator initiative with the members that you see on the right-hand side, so mixing operators and vendors to drive awareness of 5G millimeter wave technology and to explore business implementations of it. The other thing that you are looking at when you want to launch a new technology as an operator and to offer high quality of service to operators, to your subscribers, sorry, is the number of use cases that are available. Our premise at Qualcomm is to have millimeter wave as a complementary offering to mid-band 5G spectrum. So operators would deploy mid-band 5G spectrum in most of the nationwide coverage to reach most of the population, and they would, I would say, implement millimeter wave in high density everyday locations. So those everyday locations would range from left to right, from you start your work day at home, and then you take the commuting train when there is no pandemic. You go to the office, and of course, an office, depending on where you are working, can be an office for me, can be a university for a student or professor. It can be a factory for a factory worker, can be a logistics center, can be airports on the go, etc. So offices has in the wide sense of the word. And then when you go outside for lunch, you go to outdoor hot zones, and in the evening you go to outdoor street zone or indoor shopping malls, and you may end up your day back at home or in an entertainment venue. So this is what we call a day in the life, and those specific locations that we have identified during the day in the life uh, will be better served with millimeter wave, we think, because they will serve the prosumers and consumers on specific locations where there is a high density of users and where they expect to have a premium quality of experience. So in those congested areas, as Manish will show, we have equivalent QoS and quality of service and throughput and latency coming from millimeter wave as if you were under sub-6 coverage in non-congested areas. So let me show you the last part of the ecosystem, I would say, would be the return on investment for any operator. So what do we do with these use cases? It would be to confirm that there is a positive business case to an operator, which would strategically decide to deploy millimeter wave in these high density hot zone locations. So Bell Labs Consulting has done a study in September of last year, and they have applied this strategy of a day in the life into the example of the UK, a typical operator in the UK, as an example. So you can see there is really a new opportunity to cover underserved areas with the homes, up to 1 million homes, a lot of offices, and more traditional coverage of train stations, outdoor hotspots, indoor shopping malls, stadiums, and entertainment venues. When you cumulate these new opportunities and these, I would say, traditional coverage of locations, a typical operator in the UK could end up adding 8% of incremental revenue yearly across the next 5 years. So if we take one example for this brief webinar, but of course we are available to talk through all these 6 locations. But if I take the example of a train station and look at it, how would you densify your network when, imagine you have already the umbrella coverage with the mid-band spectrum, 5G mid-band spectrum, but you see that your subscribers, as an operator, you see your subscribers, there are hot zones, as you can see on the bottom left of the slide. Bell Labs Consulting have taken the example of Gare du Nord in Paris, and they have identified 10 hot zones, those blue blue ovals that you see, I'm showing 2 of them, 10 of them where high density of users warrant the need of densifying the network. On the right-hand side, if I densify with mid-band spectrum, I have a constant need to invest every year across the next 5 years. That's why the white bar is pretty stable. You need to constantly add new cells, new base stations potentially, or new cells. While on the millimeter wave side, you invest once and very little additional investment is needed, of more of the OpEx maintenance side. So the net is that you need 75 up to 75% less cost per gigabyte versus a densification with a mid-band sub-6 spectrum in the hot zones of a busy train station. So this is when I was looking at the cost side of things. And by the way, this 75% is coming from less cells, which means less power. So we calculated also that it would drive also 70% less energy consumption. So in the transition to a better planet, 75% of the cost is also generating 70% energy saving. So this was on the cost side of the equation. When I look at the revenue side and the business case side of the equation, on the left-hand side, these are the use cases that would be used in a typical train station for commuting. I'm not talking for the holidays, but I'm talking everyday train station or subway station in a very busy capital, for example. And you see on the y-axis, there is the uplink throughput, and the x-axis is the downlink throughput. You see it's pretty much uplink hungry applications that we have seen in the past 5 years, an increase of uplink driven or symmetrical applications such as video conferencing and messaging. So this is the reason why very quickly the sub-6 deployment would be uplink limited, and that's why we are saving money and driving revenue with millimeter wave. So ultimately, you reach the right-hand side business case with a return on investment of less than 3 years, with a 30% internal rate of return. That would be true at one train station, and then you would multiply this example. You would copy paste, I would say, this methodology throughout the territory that you are taking care of as an operator. And this is the multiplier effect that I was showing you in the previous slide. So if I want to summarize the business case and the entire this first section of the webinar, there is a clear revenue and cost savings increase, cost savings possibility, and revenue increase opportunity for an operator deploying millimeter wave in those everyday locations. So in a nutshell, the ecosystem of millimeter wave is now mature. The spectrum is available in many countries. The number of operators and the number of device vendors is very clearly mature enough to warrant all the demands from the operators. And we have use cases that are needed for the, I would say, hungry prosumers and consumers with a positive return on investment. So we hope that this first part have highlighted you the business side of the equation. Now I would like to turn to Manish to look at the technical and the engineering side of the equation. Thank you.
Thank you very much, Philip. So with that excellent business case update from Philip, now in the next few slides, I will walk you through some of the technical aspects and more specifically, the performance we are seeing with 5G millimeter wave in real world situations with the commercial deployments we already have today. So before I get into the specific numbers, just to reiterate some of the things Philip mentioned through his presentation, we really look at 5G millimeter wave as completing the overall 5G puzzle or the entire picture. We already have a lot of sub-6 deployments, especially outside the US for 5G, but millimeter wave built on top of it, and as Philip mentioned, built in the right places to really span through the day of your life whether you're talking of a broader operator network providing broadband service when you're out and about, or a fixed wireless service to your home where you're getting broadband speed through the 5G millimeter wave network. All of that really is complemented very effectively by millimeter wave on top of your sub-6 networks. And then as we look forward, as O-RAN solutions become more available, it will really provide us the flexibility of the deployment because of the different split options that we get with that, and the ability to mix and match different solutions and vendors and really drive down the cost of deployment lower as well. And lastly, another place where millimeter wave and sub-6 will really combine the best of the worlds and solve a lot of the complex issues is going to be for industrial deployments as well. Now, as we look back maybe a little more than a couple of years back when we started seeing the first commercial deployments of 5G millimeter wave, the focus was mostly outdoors in the city centers to provide millimeter wave coverage in downtown areas and such. But very quickly, there has been a rapid take up and deployment in a lot of indoor venues as well, like stadiums, airports, convention centers, places where you get a lot of traffic, and by being able to add millimeter wave there, you're really able to change the performance quite significantly on top of what the existing networks can do. And to put those numbers in perspective, we actually looked at the Ookla data from Q2 of last year, and I'm sure most of you are very familiar with the Ookla speed test app that is there on the phones, which you can use to test the speeds of the networks. So this is all crowdsourced data, right? This is not somebody standing under a tower and trying to run a test. This is average user going out and about and testing speeds. And it is very encouraging to see what the real world users are seeing with millimeter wave. As you can see from here, the millimeter wave experience is 38 times better than what the 4G average experience is, and even 19 times better than what the current sub-6 networks can deliver. So this is very, very encouraging data, and it proves the point that millimeter wave can actually work very effectively in commercial deployments. Then we ourselves as Qualcomm, we actually did some analysis in Chicago. This was actually my team that went out, and we looked at the millimeter wave performance for an operator, comparing that to their sub-6 deployment there, as well as LTE. And we also compared that to another operator in the same area. Now, keep in mind the two operators had different spectrum situations, bandwidths, and all of that for their 5G deployment. But as you can see from the charts here, whether you are a stationary user out and about in the city, or you're moving around, this was actually a drive test with the phone sitting in a car, millimeter wave really outperforms both the sub-6 and the LTE networks hands down. And what was also very interesting is typically the misconception with millimeter wave is that, oh, it's not really going to be able to cover effectively. You're not really going to get much coverage and all that. But in this downtown area where there's pretty extensive deployment of millimeter wave sites, what we saw was that based on the measurements we were doing from the devices, that 65% of the outdoor spaces, you had enough signal where if your phone were to try and set up a data connection, it could get served on the millimeter wave network. And once you had the connection up and running, 85% of the area, the signal was going to be strong enough where you could continue to be served on millimeter wave. So that is a pretty significant coverage, considering that this is simply right now a one-to-one overlay with the underlying LTE network. And of course, peak numbers are important, but at the same time, it is also important to understand what it translates to in terms of user experience. And what we saw in the same test was that when we were trying to stream a 4K video to these devices, again, this was while driving, not stationary in a location, we were consistently able to get the real true 4K experience with burst speeds averaging around 20 megabits with the millimeter wave network, whereas with the 4G and even with the sub-6 network, either due to congestion or due to performance, the network was really not delivering that level of experience to the device. So it really translates into difference people can see as they use their devices in these networks. Now, another study that I'd like to point out is actually done by Signals Research. And if you haven't seen this already, we actually have a link to it in the handout material that you're getting. So I would highly encourage you to download this report. It's a very interesting read. So Signals Research actually went out to two different commercial millimeter wave networks, one in Finland, the ELISA network there, and the other one in Phoenix, Arizona, the Phoenix Suns location. And so they tested these networks with multitude of devices and tried to understand what the capacity and the performance was being delivered by the network to these users. And what they did is they came up with this very interesting representation that you see in the middle, the layered cake representation there, where they calculated, like based on the overall area the network was covering in that test cluster, and the capacity it was delivering, what is the capacity density in that area, meaning what is the megabits per second the network is able to deliver per square kilometer, per square meters. So this was kind of a way to normalize what different networks would do. And what they noticed is that with the for the sub-6 deployment, which was also there from the same operator, they had the same coverage. So basically, LTE and so that's why the lighter blue color kind of with sub-6 matched what the LTE network was, but with the higher efficiency in that the capacity density was about twice, a little more than twice of what the LTE network was delivering. When it comes to millimeter wave, the millimeter wave part of the network, of course, millimeter wave being outdoor doesn't cover indoors. So the coverage is not the same as what the LTE and the sub-6 networks were covering. But the higher capacity it was able to deliver meant that your capacity density for where it was covering was 10 times what the 4G network was able to do, and more than 4 times what the sub-6 network was able to do. So this is the most important thing to keep in mind, right? Again, connecting back to what Philip was saying earlier, millimeter wave should be looked at as a solution where you build it where you need it, like Philip was describing all those different use cases or locations based on the day in your life in terms of where you need that performance. And it has the capacity, it has the performance to really amp up your experience in those areas where you need it the most. Similarly, in the indoor venue at the Phoenix Suns facility, again with multiple devices, no surprise there. What these guys observed was that millimeter wave was consistently able to outperform the underlying network, both in downlink and in uplink scenarios. Then another question that also usually comes up around performance of networks is, and especially with 5G, is, well, the networks are not loaded right now, so how will the performance be when the network gets loaded? Will I still be getting a good user experience? So this was an interesting analysis that was done by RootMetrics, and this was, again, coincidentally done in Chicago. And you can read that, go follow that link and read the more details on this report as well. And what they did is they actually loaded up the test location network by using a multitude of devices. And what they saw was that, of course, the individual user throughput reduces as you load up the network. But given that millimeter wave has a lot more capacity, and it's also a lot more efficient because of beamforming, and it's mostly a noise limited system versus an interference limited system. Even with the added load on the network, the millimeter wave network was still providing 4 to 5 times faster speeds than what the other networks were able to deliver. So again, it goes back to the point we were making that it has the power, it has the capacity, it has the performance to really deliver where you need it the most. And so then moving on to from broadband to fixed wireless. Over the more than a year now, we have been doing extensive trials with operators as well as infra partners across the globe to really see how far we can push the millimeter wave range. And where we ended last summer is that we showed this in a rural area in the US, where we were able to achieve a gigabit of user experience over 10 kilometers. So this is pretty significant for rural areas where typically the infrastructure is very less. You have very low density of sites. The population is more dispersed. So building out more infrastructure is very expensive. You don't, and that's why you have all these challenges with broadband connectivity there to homes. But now with millimeter wave, with this extended range, what it means is that a site that might be covering a large area in a rural community can now provide broadband access to a multitude of homes in that area over long distances, and really change the dynamic in terms of the performance those people can see. And of course, this translates not only from the rural area, it also translates into the suburban areas as well, where again, you can realize longer ranges and provide connectivity to more homes with this. So it becomes very interesting proposition to use millimeter wave for fixed wireless services. Then as we look forward, where we start seeing more and more standalone mode deployments coming up, we start seeing release 16 features getting commercialized this year. We will really see both sub-6 and millimeter wave come together and combine the best of the worlds, as I said earlier, to really solve the use cases and the performance requirements for applications in industrial environments. So whether it is the applications or use cases requiring like automation systems or control systems that require very low latencies or high reliability, or more bandwidth hungry applications like security cameras or maybe AR experiences for the people who are working in that manufacturing facility. So all of those things can be delivered very effectively with the combination of millimeter wave and sub-6, providing the baseline layer, baseline reliability, as well as the high capacity, high density capacity, as we saw in the previous slides. And this is something we are actually proving out in real life. So we actually have on our own campus here in San Diego, we have a live network that shows how 5G can really enable smart factory kind of deployments. And last year, in fact, working with a partner in Asia, we even deployed a millimeter wave network in a smart factory to show use cases like an AGV, like 360-degree cameras and AR glasses, VR experiences, how they can be delivered on a factory floor. And we've taken these kind of real live deployments, taken that RF model, brought that into our simulation platforms, and we've done a lot of additional analysis to show the real performance our networks, the combined 5G sub-6 networks can deliver as these things get more and more deployed. And lastly, as O-RAN becomes more prevalent, I think you probably follow the news on how all the operators are looking at moving more of their networks towards virtual networks where things are more segregated, and that allows you to achieve better, of course, flexibility of the architecture that allows you to better realize capacity where you need it and how you build your network. So all of that, as it advances, it is going to make our millimeter wave deployments a lot faster, as well as it will make it much more cost effective to build out these networks as well. So with that, I will pass it on to my colleague, Oskar. Thank you very much.
Thank you, Manish. And good morning, good evening, everyone. I think Philippe and Manish made a really good case and gave an understanding of where millimeter wave deployments stand today and what's coming up next, and what is being enabled by millimeter wave. I think from a system design perspective and standardization R&D perspective, there's a way to go for us to fulfill the promise of millimeter waves, and it's a technology that's just being deployed. It's here to stay, and we continue to develop it in 5G advanced and beyond. And there's many use cases that are still bound to be deployed, and we'll see that in the upcoming years. Right now, the focus has been in more EMBB and wide area 5G deployments. Manish talked about millimeter wave moving in the industry as well. But we're also looking into millimeter wave playing a role in V2X, side link. And actually, the side link is not really just limited to V2X, but also in positioning and in gaming. Those are also coming up. And we want to enable new user experiences, new use cases like boundless XR. Really hard. Leverage the low latency and high throughput of millimeter wave and create a great user experience in indoor, outdoor deployments. So these are all things that will hit networks in the next few years. From a standardization point of view, just to give a quick overview, we are in the beginning of release 18. So the first release 18 meeting will be in April. So this is really the second half of 5G. So 5G advanced. So you'll be hearing that term quite a bit. The first half, so the 5G initial foundational releases are over. If we look at where we came from in release 15, we had this really foundational release where we laid the groundwork for all the upcoming releases. Very rich feature set, area interface design. And from that, every release we've been building up on it. So release 16, we had the industry expansion that Manish talked about, in addition to evolution of EMBB with even things like IAB, integrated access backhaul. Release 17 expanded further in spectrum, as well as some improvements in the factory for precise positioning, for instance. And now we're in this release 18 and beyond 5G advanced, where millimeter wave continues to play a very important role. And I'll dig into a lot of those features in the upcoming slides. So Philippe made a great point to show, why millimeter wave spectrum is cost effective, and there's a lot of spectrum out there, and why we actually want to leverage millimeter wave spectrum for deployments. What I do want to point out that is on the standardization side of it, we have a very unified framework to enable that spectrum and deploy that spectrum. So we've always had the vision of having a unified area interface from sub-6 all the way up, and have the same kind of framework to enable all the different spectrums that are upcoming. So we had initially the sub-6 with the millimeter wave 2839 gigahertz as the early releases. In release 17, we've expanded that up to 71 gigahertz, so including the 60 gigahertz band. And then going forward, we are looking at spectrum beyond that, so 71 to about 100 gigahertz. And then at the right-hand side, there's the potential, the sub-terahertz, which may or may not be a 5G band, but certainly is a candidate for 6G bands. But the idea is that the standardization would address all these, enable all these spectrums in a unified design. So if we look at how all the releases evolved and all the features that came in, and I'll try to focus on just the millimeter wave aspects of it. Of course, sub-6 developed and has some unique features that also developed in this time frame. Release 15 was a very foundational design. like I mentioned. So we had the flexible framework, we had the configurability, the scalable design that we built upon. If we go all the way to release 18, in release 18 and beyond, millimeter wave continues to play a very key role, and it actually plays a very significant role. I would say release 18 is a very busy millimeter wave release on a number of fronts. So there's improvements. There's improvements in IAB. So IAB continues bringing in mobile IAB, for instance. There's the concept of smart repeater, which I'll go into briefly, where now it's a network-controlled repeater to enable more cost-effective deployments. There's full duplex coming in. So full duplex was always part of integrated access backhaul in release 17, and now it's expanding further. And then AI ML, so AI and machine learning coming into designs. So there's a study item coming up in release 18, and that's an exciting aspect where things like beam management will have AI ML driven components. So it is an exciting time going forward for millimeter wave. If we look at where we have come from in the last few releases and where we are right now, there's been a lot of improvements in millimeter wave from the early release 15 days. Improvements in power management, improvements in robustness, beam management. So every release has addressed issues to enable better, robust deployments and make deployments more cost effective. So things like improvements in integrated access backhaul. So integrated access backhaul was part of release 16, continuing release 17, and is something that has quite a bit of interest from operators for cost-effective deployments. Expansion into different spectrums, so enabling 60 gigahertz spectrum as well, and then going into the different use cases like industrial use cases. So going into the smart factory type of environment where millimeter wave, given the high spatial reuse and the diversity we can achieve and predictability we can have in a factory space to support XR and robotics and security cameras and all those aspects in a very efficient manner. So I'll go a little bit about some of the work we did on the infrastructure side and trying to enable a more robust, better coverage, more cost-effective deployment. So some of the activity has happened and some that's actually coming up as well. So the goal is actually to have a lot of diversity in the deployment in a very cost-effective way. So you can do this in a number of ways. On the left side, what we're showing is a single GNOB with distributed remote radio heads. So multiple remote radio heads distributed in space connected to a single GNOB. And that could be through a fiber front haul or wireless front haul. And that wireless front haul, so some of the upcoming sub-terahertz bands where we have a lot of spectrum is a potentially good use case for that wireless front haul. And what we've shown, so this is kind of close to the multi-TRP type of work in 3GPP. And we've showcased this in past years in MWC, some of our demos. And we see that there's a great benefit of this for robustness and coverage. In the middle is repeaters, and it's something that comes up a lot in industry, and it's it helps current deployments quite a bit. And there's different flavors of repeaters. So most of the ones you read about, you see, are these simple repeaters. So it's an analog amplifier forward, where it just sits on in the network, and it just amplifies a single wide beam to the users. And so it has some limited gain because of that. So in release 18, what's coming up is this smart repeater, something that we've showcased this past year in MWC Barcelona and Shanghai, where it's a network-controlled repeater, where the GNOP can actually control the beamforming to the UEs, so you have higher gain. So it's a more and something that's coming up in release 18, standardized in release 18. On the right side, we have integrated access and backhaul, something we've had for a number of releases, release 16, 17, and also continuing with release 18. This we can think of more as a digital repeater. So it's a decode and forward type of repeater. It's really just its own standalone base station with a backhaul. And this would be deployed very similar to how you deploy and design for deployment for a normal base station. And so what is the appeal for IAB, or integrated access backhaul? Well, on the left side, you see what is probably the typical arrangement that a lot of operators have in certain locations. So, you don't really have the density required for millimeter wave everywhere. You certainly do in downtown areas or in very urban areas, but you necessarily don't have it in everywhere and for every operator. So the fiber backhaul may be only in certain GNOBs, while you have to densify quite a bit more for millimeter wave. So if you look in the middle, what IAB allows you is to place those IAB nodes at the density you need without having to run fiber backhaul, which is actually a majority of the initial cost. And as the traffic capacity needs grow, then you start running fiber backhaul to all the different nodes, either a subset of them or in this picture, all of the nodes. So it's really a kind of a phased investment, a phased way of deploying millimeter wave in certain areas. So that is really the appeal for IAB. Just to shift a little bit, so we have, as I mentioned, made also a lot of improvements in beam management to constantly improve the robustness and network robustness as well as phone robustness. Things like enabling multi-panel functionality on the UE, so decoupling the uplink and downlink beamforming. And then on the right, we talked about the L1, L2 intercell mobility, which is something that we'll be showcasing this year as well in the external demos, where millimeter wave cell boundaries are very loosely defined, and you may be switching between TRPs very frequently. So to have very efficient handovers across different cells is very important. So having to do L3 handover can be very disruptive to user experience. So we've improved that with having some kind of a quick L1, L2 intercell mobility. And finally, we've also started, we've also been working quite a bit on saving the power consumption on the UE. And that's continually evolving in every release. And some of these we've showcased in Mobile World Congress this past year. We've made improvements on the way carrier aggregation works, for instance, where the UE now only has a primary cell and the other carriers get added as needed. So it's, we reduced the number of carriers that the UE has to monitor. We've also had more efficient ways of monitoring PDCCH. So we have PDCCH skipping. Certain traffic or applications have very fixed traffic patterns like XR. So there's really no need to monitor PDCCH all the time. So we enable ways of skipping it and kind of scheduling PDCCH monitoring. And then we've also looked into ways of improving wake-up radio, beam management in wake-up radio, so that when the UE wakes up, we don't have to do a full scan from scratch and waste a lot of power in the meantime. So we have, so that's also something that's been standardized, and we show the benefit of it in our Mobile World Congress demos. So a lot of the features that I've mentioned are things that we have either tested on our OTA testbed, indoor and outdoor OTA testbed, or we've simulated extensively and presented externally in Mobile World Congress and other venues. So we've looked into the benefits of repeaters and smart repeaters and done the full comparison, and that's something we've believed strongly in, and that's why we've supported the work in Release 18 as well, and we look forward to that work. We looked into smart factories and the benefit of millimeter wave in smart factories, and that looks very appealing use case. We looked at how machine learning and AI can really benefit millimeter wave deployments, and that's something that we've presented, and we'll also have another demo coming up this year, how beam management can not only improve robustness through AI, but also save power on the UE by reducing the number of reports that required from the UE. So I encourage you offline to click on the links in the handout and watch some of these videos and understand where millimeter wave is going in terms of standardization and capability. So where current deployments will go in the next few years, all the features that will be coming up, and see really the full potential of millimeter wave, and a potential that I hope to see fulfilled in the upcoming years. I want to thank everyone for joining, and I think we have some time for Q&A now.
Great. Thank you so much. All right, so now we're going to be moving on to the Q&A portion of our webinar. There is still time to submit your questions using that Q&A tab to the left of your screen, but we do have a lot of great questions already, and we'll try to get to as many as possible. All right, so to kick us off here, our first question, and this is for Philippe. Can you talk about the real progress so far in deploying millimeter wave for the everyday high-density locations that you've referred to?
Yes, thank you, Liz. So the premise, you remember, as we said for these everyday locations, is really to complement mid-band coverage with millimeter wave coverage in those high density locations. So while the mid-band coverage would have a wider coverage. So the example that comes to mind is Japan. As I have mentioned, the four operators in Japan, Docomo, KDDI, SoftBank, and Rakuten, have all commercially launched millimeter wave in the course of last year, at the first half of last year. And they are deploying, there is no surprise, they are deploying those millimeter wave in those places, in those everyday places. I don't know if some of you know how, for example, Tokyo train stations are listed along the JR line. They are located in very busy districts of Tokyo, where you have a lot of offices, where you have a lot of like outdoor shopping streets, where you have indoor shopping malls and train station, as I said. So in reality, this is the perfect example of how super high dense locations like the dense urban area of Tokyo can handle those high capacity locations for demanding user. Another example would be Verizon that have now deployed millimeter wave in parts of 87 cities. So for urban deployments like outdoor deployments, but also 5G home, what they call 5G home, which is fixed wireless access in parts of 65 cities, and 5G business in parts of 62 cities. So again, when you talk about business, you think offices, like small and medium offices. When you think 5G home, you are talking about the home, the fixed wireless access, and the urban, dense urban areas. So again, this notion of deploying millimeter wave where it matters in those everyday locations. So these are, I think, two great real life high profile examples.
Great, thank you so much. All right, so moving on to our next question here, and this question will be for Manish. One challenge we have in any cellular system is uplink performance. Can you talk a little bit about how millimeter wave can do for uplink?
Yes, certainly. So if you look at the commercial 4G networks today, like for example, if I just take an example from the US networks, on a 4G network today, your typical experience would be hitting peaks of about 60 megabits per second on the uplink. So suddenly, compared to what you would be getting on the downlink, the performance is somewhat limited. And of course, it's in some ways by design as well, because typically most of your traffic is downlink. But now if you compare that with what we are seeing already with the millimeter wave deployments, again, staying within US, we are able to achieve peaks of about 200 megabits per second on the uplink with some of the commercial deployments here. And last year in fall, we already demonstrated achieving 700 megabits with more carrier aggregation on the uplink. So millimeter wave this way, given playing into what all the things we already covered during the webinar, with the overall higher bandwidth, higher capacity, higher performance, is going to be able to deliver a lot faster uplink, a lot more capacity to be able to power all the applications we are seeing.
Great, thank you so much. All right, let's move on to our next question here, and this question will be for Ozge. I saw that 3GPP just decided on the scope for 5G Advanced Release 18. Are there any more enhancements to millimeter wave?
Sure. So I think that's a great question because we are at the beginning of release 18, and as I mentioned, release 18, in fact, is a very busy release for millimeter wave. I think it's expanded quite a bit because people do understand the value that it brings, and all the features that we have been talking about for a number of years are really now coming into the standardization body. So we have things on both sides for improvements on the UE side with more functionality, as well as on the network side. So integrated access backhaul continues. So we have this mobile IAB now, where vehicles with a mobile IAB node can provide coverage to surrounding areas. We have smart repeaters, which are network controlled repeaters with beamforming enabled on the repeater. That's being standardized in release 18. That will also enable, along with IAB, so cost-effective deployments with more robustness. We have full duplex moving beyond just IAB into the access network. So that's not on the phone, but at least on the GNOB side. And we have AI/ML that has a very strong component to play in millimeter wave. So one of the things I mentioned was beamforming, beam management, and how AI can play a great role in enabling robust and power efficient beam management. And then even things like sidelink have a very big millimeter wave component, both in direct communication as well as in positioning. So to enable more non-line of sight type of positioning through sidelink, centimeter level accuracy through a millimeter wave. So it's so these are just a few things, but it's really just a lot more than that. It's millimeter wave is really expanding, and it's a great release for new features.
Great, thank you. All right, moving on to our next question here, and this question is going to be for Philippe. What about China adoption? What is your vision?
Yes, of course, China is an important piece of the world map. So as you have seen the world map I was showing, so trials are happening in China, and spectrum allocation is in good progress, good process. Not allocated yet, but good progress as we were expecting. So what is understood from the Chinese ecosystem is that commercial launch could happen next year, sometime in 2023. So of course, what is important here is that we are going to have also the ecosystem of China, the vendor ecosystem, the device ecosystem that will also pop up and being boosted by their domestic market. So not only boosting their domestic market, the China domestic market, but also, of course, being those, I would say, high visibility brands worldwide for devices like Vivo, Oppo, Xiaomi, Honor, ZTE. We will benefit from it also from a worldwide basis by the appearance of more models enabling millimeter wave outside of China. So it's a kind of win-win situation where the delivery of millimeter wave in China commercially will foster a wide ecosystem worldwide that all operators around the world will benefit from.
Great, thank you so much. All right, getting into our next question here. And this question is going to be for Manish. Does millimeter wave need repeaters to make it feasible indoors?
So no, not necessarily. So repeaters have a different purpose. Basically, Sure, they can be a solution for indoors as well, assuming you could have the donor signal coming from outside. But typically, repeaters could be used for outdoor deployments as well, to provide coverage in an alleyway or wherever you're trying to get coverage where maybe it's not getting covered with a macro site. For indoors, we already have a lot of other solutions that are already commercially available and are being deployed. As Philip talked about Verizon a little earlier, Verizon already has significant millimeter wave deployments in indoor areas like stadiums, NFL stadiums. Most of them have millimeter wave, which is right now built primarily using the macro sites itself. You have various small cell solutions that are available as well from multiple vendors, which are already getting deployed as well, which provide a very effective and cost-effective solution for indoor deployments as well. So certainly once repeaters get more prevalent, they will also have their place, but there's a lot of other solutions already in the marketplace to enable that same thing.
Yeah, maybe Liz,
Great,
if you
thank
want,
you.
I may add something from the business side, because this is a very good question that remind us that the basic of the business case that I was showing and working, of course, hand in hand with Manish and his team to work out the technical assumptions behind is that the primary aim we were trying to do is outdoor to outdoor coverage. So meaning deploying small cells or macro cells outdoor for outdoor use cases, and indoor to indoor coverage for indoor use cases. So the train station, for example, would be indoor to indoor coverage. So in a sense that limits, we want to make it easy for operators, to decide. As I said, 2022 will be the year of millimeter wave for key decisions by key operators around the world. Therefore, this first phase should be as easy as possible. So outdoor to outdoor deployments and indoor to indoor deployments should be, I would say, the rule, where repeaters are maybe less needed. And then, of course, as we extend coverage, repeaters, or as Özgür said, integrated access and backhaul would be a solution that can extend the coverage further out.
Great. Thank you so much. All right, and moving along to our next question here. And this question will also be for Manish. How fast can a user move or travel to get the benefits of millimeter wave data rates and coverage?
So maybe I guess I'll interpret that question as, is there any impact of high speed or mobility on millimeter wave performance? So from the testing we have done, like the data points I was sharing from the Chicago market, we really see that number one, there's very widespread availability of millimeter wave coverage in the outdoor areas. And as we are out and about and moving in those areas, we really see no impact. As we saw, the millimeter wave network was performing significantly better than the sub-6 as well as the 4G networks that were there in the same area. So certainly from that perspective, there is no impact. And then if the question is, okay, can we really break it at some point? Like, will Doppler create any issues? So I think again the answer there is no. Of course, we haven't tested it in very high speed scenarios, but there's also a lot of research that has happened in that area. And maybe Oski, I don't know if you would want to add something more on that from that perspective, but certainly there should be no issues.
Yes, I do agree. So a lot of the deployments right now have been in I would say urban areas where maybe the velocity is not that high. But if we do look at use cases, whether they're trains or highways, I do believe millimeter wave plays a role there as well, because at those high speeds in those type of environments, it is kind of predictive. So you know where the train is and you can follow the train in a very predictive way. And highways are also very predictive, and I think it's a great use case for data offloading into cars, especially as we go into the future for autonomous driving. So there's a lot of capacity to offload in these very high speed use cases, I would say.
Fantastic. Great, thank you. And that was actually the last question that we had time for today. We had a lot of great questions come through today and didn't have time to get to them all. So we will try our best to get back to everybody who submitted a question personally after this webinar. This webinar thank you for attending this Fierce Wireless webinar and for submitting so many great questions. I'd like to thank our speakers for participating and Qualcomm for presenting today's webinar. This webinar has been recorded and you will be able to access the recording within 24 hours using the same audience link that was sent to you earlier. Thank you again for joining, and we look forward to seeing you at future events.